Hello, good morning, Nilesh sir. Nilesh sir.
Hello,
So
good
good morning,
morning, sir.
all the participants. I can see we are getting number of participants. So many participants are outside.
Sir, your
So
voice is
before the
not
event
audible
start, I'd
correctly.
like to share something. So first of all, that event is containing short-term courses containing three, four topics. So the now question is why we are including three, four topics?
Sir, you are not
Because
audible correctly.
in a single topic we have been given, but we thought that when PhDs and research scholar students are so give the exposure on different topics that is currently going on in research and research. So we have speakers from research in they say that there is a recent trend going on as a research. We have speakers from industries, well-known industries, industry, from communication. So they will talk what is the recent technology going on in market. And we have also academicians, those who talk about the research aspect, how to proceed with that.
Nanda, sir, you are
So
not
basically,
audible
this
correctly.
divides the topic will show the recent trends. So that is the one thing I wanted to see. And another thing, at the end of every day, we'll be sharing one feedback. So everyone has to fill the feedback link and send and submit the feedback in time. Be giving it a time duration. So at the end of each day, we'll be sharing the feedback link. That is just at 4 p.m. 45, it may be 4:50. So that you are present by that time, so that
Sir, excuse me, sir.
feedback form.
Sir,
Nanda,
voice
sir,
is not clear, sir.
So
Voice is breaking,
Nanda,
sir.
sir, your voice is not clear, sir.
can continue.
Just wait. I request the participant to wait. Nanda, sir, your voice was not clear when during your talk. So you can share the information once again.
Hello.
Hello, Nilesh sir.
Sir, Nanda, sir, your voice was not clear during the talk. You can repeat the relevant things again. We are going to start the session in a while. So I request all the participants to connect it together. Thank you all for connecting with us. Now we are going to invite our first speaker of the session, Dr. Devi Prasad Das. I would like to thank sir for giving this opportunity to hear us from him. Dr. Devi Prasad Das sir is currently working as a principal scientist and head process engineering and instrumentation department, CSIR Institute of Mineral and Material Technology, Bhubaneswar, Odisha. Dr. Das has received PhD degree in electronics and instrumentation engineering from National Institute of Technology, Rourkela, India in 2004. And he has worked in various academic and R&D institutions at various capacities. He has guided 6 PhDs and 5 are ongoing under him. His research interests include development of monitoring and control system using electronics and instrumentation techniques. He uses various advanced signal processing, artificial intelligence, and machine learning algorithms in his recent projects. Also, Dr. Das is a recipient of the Odisha Young Scientist Award by Government of Odisha, India, CSIR Young Scientist Award 2009 by CSIR India, and Boys Cost Fellowship received during 2009-10 by DST, Government of India, also an I Engineering Impact Award in 2014, and AICT INAE Distinguished Visiting Professional 2018. He is also selected as a mentor of change for Atal Tinkering Lab in 2018 by NITI Aayog, Government of India. So now I would like to welcome Dr. Devi Prasad Das sir to address us and enlighten us with his presentation title of Basics of Artificial Neural Networks and Convolutional Neural Networks.
Thank you, sir.
I'd like to welcome, sir.
Thank you very
Yes,
much
sir.
for your great introduction. Am I audible clearly?
Yeah, you are audible, sir. Please, you can
Okay.
start.
Thank you for giving me an opportunity to share my knowledge and experience in the area of artificial intelligence, particularly artificial neural network and convolutional neural network in this particular talk. So, can I share my slide?
Yes, sir. Yeah. You can say yes, sir. Yeah.
Okay. Hope my slides are clearly visible.
Yes, sir. Your sides are clearly visible.
Okay. Thank you very much again for inviting me to talk to people who are interested to learn something in the area of artificial intelligence. Nowadays, you know, everywhere people are talking about artificial intelligence, machine learning, data science, big data analysis, so many things. And there are Python codes and MATLAB codes. You can just download it and you can make your own applications of artificial neural network, or CNN, convolutional neural network, or deep learning, or a face recognition based system, or a communication system. There are tools and codes available. You can just download it and you can try yourself. But the issue is the codes are developed by somebody else, and you are only just downloading it and just giving the input and output and getting your work done. So then our scope of improvement of those codes are very limited. We cannot go inside what is there inside a gradient optimization technique, how to change the convolutional neural network, the different layers of the network, how to change the convolution operation, how to change the fully connected network. Those are very limited, and we are generally not doing. Okay, and there are people who are mathematicians or good computer science people. They have referred some research papers and developed standard codes. And as a software company person or a user or scientist or a PhD scholar. He just has to bring that code and apply for a communication system or a MIMO system or a 5G network or a instrumentation and control system. Just bring it and use it, or image processing application, bring it and use it. Write few lines of Python code. But now this particular talk will be little different. I'm not going to tell about which function is required for ANN, which function is required for CNN, but I'm going to tell what are the things being used inside ANN and inside the CNN, so that even if you don't have a code, you can also write everything from the scratch. So my content is a little bit of artificial intelligence, I will tell, because there is a clear-cut distinction between artificial intelligence and machine learning and neural network and convolutional neural network. They're all not same. They may be subsets of something or superset of something, but they are having different applications and different concepts. So artificial intelligence, machine learning, relation between machine learning and a curve fitting. Many people know about curve fitting. Because if we have a lot of data, then we can fit it to a line, straight line, or a quadratic equation, or a curve or a polynomial equation. That is called curve fitting. I will also tell about curve fitting if you are not aware about it. And I will tell about the basics of artificial neural network. And there is something called backpropagation algorithm. Under backpropagation algorithm, can be done by many methods, but one of the technique which is very prominent and used at many places and very old, that is called gradient optimization. So what is the basics of gradient optimization, I will tell. And what are the different varieties of training and testing, that I will also try to cover. And then I will go to the convolutional neural network and tell you how the CNN is different from ANN. In convolutional neural network, there are various operations used like convolution, pooling, fully connected networks, softmax. All these operations we will be explaining, very basics of that. Then there are some well-known CNNs. One of them is AlexNet. There are many other CNNs also, but AlexNet will deal in detail. And other nets, I will tell the basics about it. Then there is a concept called transfer learning of the convolutional neural network. What is the importance of transfer learning, I will tell. Then during training, you require a data augmentation. So that also I will cover. So first of all, let us know what is artificial intelligence. You know, brain, our human being is told to be the intelligent creature of the world. There are many living organisms, but among them, we say that human being is the most intelligent. Because of that, they are also trying to know whether ant is more intelligent in some aspect, or the bees are more important, more intelligent, or more capable than human being, or they can make a machine which will be equivalently intelligent to the human being, or it is even more intelligent than human being. So when a machine is made intelligent, that is called artificial intelligence. So artificially we are making a machine intelligent. Machine is not a motor or a generator. Machine over here is nothing but a computer, okay, which has got a learning ability, which has got memory. Okay, so but artificial intelligence may not require learning. Okay, it may be just kind of logics. You can have a logic. If suppose in a particular room, one AC, suppose air conditioner. Air conditioner can be a normal air conditioner, what is available at the moment, or it can be an intelligent air conditioner. Intelligent air conditioner means whatever is required for the air conditioner to be done, air conditioner is required to cool the room or maintain the room at a particular temperature, and using minimum energy, okay, minimum noise. And whenever you enter into the room, that should be cooled. So how it can be made intelligent? You can have temperature sensors, and accordingly you can control. So those are already done. Now you want to make it more intelligent. How you want to make it more intelligent? So you can incorporate something so that AC will run and it will consume the minimum energy. Means it will switch off when no person is there inside. then it can also predict that around 10 o'clock or 9:30 the person is going to come. Okay, and he will train himself that what is the probability that this person is going to come inside, or the owner of the room is going to come, or more number of people are coming. So he will have last previous days trained, know that during morning 9 o'clock to 4 o'clock it is having more gathering. Lunchtime 1 to 2 o'clock there is nobody there. So accordingly it will run and keep the room full with minimum energy. Okay, so that is a kind of artificial intelligence, and it has to learn from the previous experience. Okay, it can be just a logic, or it can be a model which is used in machine learning. So it indicates any form of technology that includes some intelligence aspects rather than pinpoint a specific technology field. So we are not saying this artificial neural network is artificial intelligence. We are not saying convolutional neural network is artificial intelligence. It can be anything which includes intelligence. That is called artificial intelligence. But under artificial intelligence, there is something called machine learning. So machine learning can also make a machine intelligent. Okay. So in machine learning indicates again a specific technological group of artificial intelligence. And machine learning itself include many technologies under that. Under machine learning, you can have CNN, ANN, deep learning, so many things. Okay. One of them is deep learning. Nowadays, many people talk of deep learning or CNN. Okay. So deep learning has been in spotlight recently, as it has proficiently solved many problems that have challenged artificial intelligence. Earlier days, artificial intelligence was unable to solve certain things, but with the invent of deep learning, now we are able to solve many things which were remaining unsolved. Okay. Then under the convolutional neural network, a portion is called artificial neural network. But when the artificial convolutional neural network was not developed previously, we were using artificial neural network alone. Okay, now convolutional neural network is built upon artificial neural network. Whatever was the shortcoming of artificial neural network, that was removed, and some additional functionalities are added, and it is made as CNN. And CNN is a part of deep learning. Okay, under deep learning there are many things also, but CNN is just one part of the deep learning. Okay, so what do you mean by machine learning? You can see at the right side some handwritten characters are written 1 5 4 3 5 3 like this. Now as a person, if I see this 1 5 4 3, then I am able to tell this is 1, this is 0, this is 3 like this. Okay, but whether this 0 and this 0, they are different, they are looking different pattern wise. This 5, this 5, this 5, all these 4 5s are there, they are written differently, but to a human being they are all 5. But if you put into a computer, sometimes this 5 will be called as 6, or sometimes this will be looking as 6. Okay, so you have to make the machine intelligent in such a way that all that whatever human is able to decipher or recognize, the same way the machine can also be able to recognize. So machine learning is a terminology. It has got 3 things. Okay, it has got mainly 2 things. One is called model, another is called data. Okay, so basically this model is to be trained using the data. Okay, there are 2 things, terminologies you need to remember. One is model, next is data. So data can be input data and output data. Data will be again of 2 types, input data and output data. So data can be audio signal, maybe a voice, maybe a Facebook post or a Twitter post, or it can be image, it can be a document in a book or a research paper, or it can be a signal coming from a temperature sensor or a pressure sensor. So anything can be called as data. Data is just not an Excel file. Okay, data is anything. EEG signal or a chest X-ray which is already captured and kept somewhere. All these are called data over here. Okay, and the model is the final output of the machine learning. So suppose you do a machine learning, then what it will give after it is learned, it will give a learned model. It is a model which is already learned based on the data. Okay. So model is the final output. So that you store. Now you give new data and it will generate new output, and which is realistic output. Like a normal physical system giving an output, you are also going to get the output. For example, a chest X-ray, a doctor is able to see and tell whether he is COVID or non-COVID, okay, by just seeing the chest X-ray. Similarly, if you have a chest X-ray input to the model, so model is nothing but a mathematical program. You give the chest input and you get the output as COVID or non-COVID. So that program is called the model. Okay. So machine learning is not only the only modeling technique. So there are many other modeling techniques also. I told machine learning gives a model. Okay, by using machine learning, you can generate a model, but it is just not the only thing that only machine learning can give you a model. Model can be generated by many other means. That is why the next point I say, machine learning is not the only modeling technique. Okay, there are other modeling technique also, but machine learning can also give a model provided you have the data with you. Okay, machine learning is also called a data-driven model, or these models are called data-driven model. Is this all right? So there are typical problems can be found where intelligence is involved, such as image recognition, speech recognition, and natural language processing. We know nowadays attendance system is done by face recognition system. That is called image recognition system. Speech, you tell something, then the other side, the automatic IVR system can know that it is the same person is speaking. It is not the another person. Okay. Natural language, you tell in Odia or in Telugu or Tamil, then the computer will be able to understand. Just not the English is required there, or you need not type it. You can just tell it and it will recognize. Similarly, machine learning can be of three types: supervised, unsupervised, and reinforcement learning. Okay, but we will only cover the supervised learning here and unsupervised learning. Okay, unsupervised I am not covering here. Here only we will cover the supervised learning. In supervised learning, you have the input data and the target data both required to make a model. In unsupervised learning, you can have only input data, and based on the input data, you can create a model, and that model can be used for an application called classification application. Okay, or clustering application. So it can only be used for clustering or classification application. Like for example, if you give the data of your school, the marks secured by all the students of your school, then one expert can take all the inputs, then he can tell that in your school, there are 20% students who are very poor, there are 50% who are good, and there are another 30% people who are the best, okay, who can be trained further. Okay, just by seeing the data, you have not told who are good, who are bad, but just seeing the data, he is able to know. That is called unsupervised learning. You have not trained them. You have not told that these are good or these are bad, but he will categorize and say this is your students are three types. Okay. And there is a reinforcement learning. This is mainly used for a different type of control applications. So we are not discussing now because we have got only 1 hour time and I have to cover a lot of things. Okay. So as I told you, machine learning is going to generate a model. In this diagram, I have shown a model, and this model can be made using ANN or artificial neural network. It has got input and output. So input and output are called the data, and model is nothing but a mathematics. Okay, it's an equation, and the equation has got a structure and also having some parameters. Okay, and different type of structures can be possible. And to get these parameters, you need optimization algorithm. Okay. So now I need to tell a little bit in the whiteboard. Tell you something. So I just use the whiteboard here. So as I told you, suppose you have got some data. Okay. Suppose this is X or X1, this is X2, and this is Y. Okay, and you can have, let's say, 0.1, 0.2, for this output is, let's say, 0.4. Like this, you have so many data, 0.5 minus 0.1, 0.9. Like this, let's say you have so many data here, so many data here, so many data here. Now you want to make a model, okay? You want to make a model where two inputs are there, okay? There are two inputs, one is X1, another is X2. And you have got one output. You have got one output. This is Y. So this is your ANN. This can be one ANN. So one can say, I just keep this table. This is a table, okay? I can just keep this table inside, and whenever 0.1 and 0.2 comes, here 0.1 and 0.2 comes, this will be giving 0.4. I can tell that. But they will not have all the points. So you can have only one points like 0.4, there will be another point 0.9, there will be another point something like this. You cannot get the in-between points. Okay, you don't have information about in-between points. Okay, so that is why if you can make an equation here instead of a table, okay, so table will give only discrete values, but if you put an equation, any values of X you can give. Instead of 0.1, you can give 0.11. So you will have another output. It will not be 0.4, it may be 0.44. Okay, so like this, your objective is, once you have a data from experiment, you want to make the model by using ANN, so that you get the output. And this model is nothing but your experiment. This model, what you are going to get is your experiment. So in the experiment, you are given in two inputs. Like suppose you are giving a concentration and a temperature. Suppose one process control you are doing, you are changing the concentration of the reagent, and you are also changing the temperature, and you are getting the productivity. Okay, so productivity is this. For this concentration, this temperature, this is the productivity. For another concentration, another temperature, another productivity. Like this, if you get, now all the data are there with you, and you can make a model. And with the model, you can actually generate. Next time you don't have to do the experiment. You put a new concentration and new temperature. You can see what will be my productivity. Will be increasing or decreasing. Okay. So what I am doing here? Here I am saying y is nothing but a function of x1, x2. Okay, 1 x1, comma x2. Little bit of mathematics we need to know, because this artificial intelligence covers some mathematics. So I can say this y equal to a0, the constant, into x1, okay, plus a2 into x2, or a1 into x2. I can say that, but this is called a linear equation. So this may not cover the whole data set. Means suppose you have data here, but your datas are here like this. So many data points are there, but you can only fit a single line, straight line, by using this equation. But if you want to get the data, all the data here covering, then you go for a non-linear equation. So to make it non-linear, you have to cover x1 square, make it square, or x2 square, or x1 into x2. All these are non-linear terms. Okay. Then x1 square into x2. So there are many varieties you can make. Or sine of x1, sine pi of x1. Sine phi of x1. Okay, or you can have e to the power x1. All these terms are nonlinear terms. So this x1 is converted to nonlinear terms and you can get y. Okay, the same thing I am going to explain here. So if you have got one input, only x, then your y is a function of x, or y can be a function of multiple inputs. You have x1, x2 up to xn. Okay, so what do you mean by model structure? So when I say that suppose this one is there, I can make it in a structural form. Like I can say it is x1. X1 is multiplied with a0. So I just put an arrow. Then it comes over here. I have got x2. Then it is multiplied with a1. Then both are summed up. Okay, sorry, I'm just using a mouse, so not proper. So this is why. So this is, instead of writing an equation like this, I can make a structure diagram. Okay. Now suppose I want to add x square. So same x I will take. So I will multiply. I can put a multiplication symbol here, and one more x I will take from here. So this x is going, this x is going, and I get what? I get x square. So here it is becoming x square. Then I can multiply with another thing called, let's say, b0. I multiply b0. So this is called a structure. So this whole diagram is called a structure. And you see this b0, a0, and a1. They are called the parameters. And depending on the table, objective is to find the parameters. Okay, find the exact parameters. So b0 maybe sometimes 0.1. Okay. Finally, after training, a0 may be -2. Okay, maybe something -2, or a1 may be 8. Any number. Okay, it may be plus, minus, any number it will become. So they are all one scalar numbers, just numbers. Okay, and once these values are fixed, then you can say whatever this model giving y. So let's say I say it is y estimate. So I can have y estimate here in the table. Okay, so y estimate, and I can say that for this particular input 0.1 and 0.2, this is 0.44, but I am getting 0.46. So there is little bit of error. Okay, model cannot be always 100% accurate. So the error will be 0.02. Okay, another person will make another model. Their y estimate will be 0.441. That means 0.001 is the difference. This 0.02 difference, it can be 0.00, 0.001 difference. Sometimes you can say 0.301 difference. So there is a error at this level. So this is minimum error. So this is the best. Then this is better. And this is also okay. Okay. So like this, you make a model and see that your error is minimum. Okay. And another objective is how much computation you are going to do. In this particular case, how many multiplications we have done? Who can tell? Can the participant also speak? Hello.
Yes, sir, you can continue, sir. No problem.
No, the participants can also speak or not? Or they can?
No, sir, they are
muted.
Mute. Yeah, muted.
Okay.
All are
Okay, you can write in the chat box, or later on at the end you can tell. So my question is, in this particular thing, how many multiplications are there? You can say this is one multiplication because x and x are one multiplication. This one multiplication. This one. 1, 2, 3, 4 multiplications are there here. Okay. So this is a structure. That is why I'm saying the model has got a structure and got some parameters. So in this calculation, I say the whole diagram is a structure, and this particular equation is also called a structure. And this A0, A1, A2, AR, B0, all these are called parameters, and these parameters are required to be tuned to find the optimized output. Okay. And you know, there are various types of models like Ebor model, this spring mass model, or a rocket launching model, or this FIR filter model. So all these models are nothing but mathematical equations. So some input output equations are there, and objective is to find out these parameters so that the actual system and the model are matching. Okay, actual system and the model, they both match with minimal error. Then you need not do the actual experiment, and you can actually getting the model, you can do simulations. Okay, so model is nothing but mathematical relation in simple term. And you know, I said machine learning and curve fitting are related. You know, many experiment you develop varieties of data. For example, in this case, concentration versus instrument reading. There is an instrument, you actually have, you vary the concentration, okay, 0.1, 0.2, 0.4 like this, but the instrument is reading like this. Instrument is reading this for this particular data. For this particular data, the instrument is reading this. So then suppose you want to know what is the sensitivity of this, means reading for concentration. Okay, so you have to fit a line. How will you fit a line? In this particular thing, there is an equation written, fx equal to 9.79x plus c. So you know, a straight line equation, y equal to mx plus c. Y equal to mx plus c. So this x is the input and y is the output, and this m and c are the parameters. So this is one parameter, this is another parameter. So given this data sets, you can get this m and c parameter. Okay, so and this is called a linear equation. Okay, if it is a second order equation, this one is a sixth order equation. So the power is 5. Okay, up to power 5 is a sixth order equation. This can be second order equation. Okay, or third order equation, fourth order. So data is like this. So this 1, 2, 3, 4, 5, 6, 6 data are there. Are you fitting like this a straight line, or this type of curve, or a curve like this, or a curve like this, or a curve like this? So when you are fitting using this or a sixth order polynomial, you are finding all the points are touching. All the points are touching. But is this one correct? Best one, or this one is best, or this one is best, or this one is best? If you watch it carefully, you can see this shows that data are actually remaining from here to here. From this range to this range, data is remaining. Okay. So from this range to this range, data is remaining. So if you fit like this, then data as if it is going down and coming up like this. Okay. So which is not a best fit, which is not a best fit. This is called overfitting. This is called overfitting. So you in a machine learning, you also need to have reduction of the overfitting. Okay. So basically, you have to design a function that is called the structure and find the parameters best fitting to the data. In this particular diagram of the data sets, you can see some data are coming up to this, some data are coming up to this. So you can fit a nonlinear model like this, or you can have two models, one model from here to here, another model from here to here. Okay, there are two linear models at two different ranges. You can make and make it fitting. Okay, so far I have not told anything about artificial neural network, and I am only telling about curve fitting, equations, data, models, parameters. This is because based on this concept, our artificial neural network is actually developed. So this, okay. Now suppose how to find out, now next is how to find out this A0, A1, A2, A3 values. Okay. If I have got data, So as I told you, you have some data like x1, x2, y, and using this data, you want to find this model. So values of a0, b0, a1, you want to find out. So this is the method called gradient optimization method. For example, you have a data table. Okay, suppose you have data. So you have got x and you have got y. Okay, let's say y x equal to 0.1 and y equal to 9. Okay, then 0.5, y equal to 2. Okay. Suppose this is the data. Now what you need to do is first you feed this data. Okay, which data? 0.1 you put here. Okay, and you take m equal to 0 and c equal to 0. So if m equal to 0, c equal to 0 and put 0.5 here, then what will be the output? Output also will be 0. So you are getting output 0, but actual output d or the y here. Okay, in this case, let us call it as d because this is called desired, and but this is actually 9. So you have got 9 and this 0. So plus minus 0, you get error as 9. And this 9 will be used to actually change these values of m and c. Okay, m value will be changed and c value will be changed. So how it will be changed? By using a gradient optimization technique. Basically, is optimization technique which you have studied already in mathematics. So basically, error equal to desired minus output. Then take the square of the error. The square of the error is to be minimized. Why square of the error is minimized, not the error minimized? Error can be positive and negative, and minimizing a negative number can be further negative, which is more deviated. That is why error is not minimized. And if you square it, everything becomes positive, and then if you minimize, actually the absolute value of the error is going to reduce. And this is the technique by which you minimize. Okay. So whatever is the m value, present m value, then you need to change. So present m value was 0. Now you need to get a new m value. Okay. You have to get a new m value. How you will do? You have to minus mu into del e square by del m. So e over here is d minus y. So if you calculate del e square by del m. So what will happen? We know square of something derivative you take 2 into e, okay, into del e by del m. Isn't it? Then you keep 2e here. So in place of e, you put d minus y. Okay. Here we have put e equal to d minus y. So you can use this equation in this here. So now you have got derivative of d minus y by del m. Okay. Now d is a constant, so derivative of constant is 0. So you get 2 into e. Then del minus y by del m. So all of you please solve it. Okay, I have less time. So what you are going to get? See y equal to mx plus c. So when you take the derivative with respect to m, what you are going to get is 2e del. So since this minus will come out. Del m x plus C. I know if I clear this, then rest of the things I don't take much time. Okay, then del M. So here there is no M, so this will be 0. Only del Mx by del M equal to how much? Minus 2 into E, then only X. Okay. So with respect to M, if I take the derivative, I get minus 2 into X. The next time I will take derivative with respect to C, then with respect to C, then this will be minus 2 into E into 1. Okay. So into 1. So minus 2E. So when I take the derivative with respect to C, then this will be minus 2E. If I take derivative with respect to M, it will be minus 2EX. Okay. So then you replace here, then you get the update equation for M and C. This is called gradient optimization technique. Okay. Then you will be able to get finally this M value. If you iterate it, you first give this data, then next data, like this go on, complete, again come back and give this data, like this complete. So if you repeat this, then finally you will find the error is 0 and your this data, finally this M will become 9.7 and C will become this. Okay. And this is going to have a good curve fitting. So I already explained over there. Then what happens if the model is not just Mx plus C and model is A0, A1, A2? So similarly, you take derivative with respect to A0, derivative with respect to A1, derivative with respect to A2, then you will be able to get it. Okay. So sometimes there may be confusion that I am taking minus over here because I am going to minimize the error. Okay. If some cases you want to maximize something, then you take plus over here. This is a gradient optimization technique principle. What is the difference then same y equal to mx plus c and the artificial neural network? Same x1, x2, x3 are there. Then instead of m and c multiplication, you have got w1, w2, w3. Then they are summed up with a bias. So bias is considered c as c over here. It is a constant. Okay, it is not a dependent quantity than the input x, and you get the output finally. So this is the structure. And what are the parameters over here? W1, W2, W3. These are the parameters, and these parameters are updated using gradient optimization technique. Okay, this is called a neural network, and this is called a single layer neural network. So this is a single layer neural network which is having no hidden layer. If you have single hidden layer, so this is the input, this is the output, and these are the hidden layers. Okay, this is hidden 1, this is hidden 2. So like this, there may be multiple hiddens. If the hidden layers are more, then this is called a deep neural network. If it is less, it is called a shallow neural network. Okay. So you can see some of the structures: single neural network, multi-layer neural network, deep neural network, more hidden layers. Okay. Now simple calculation you can do, since the slides are recorded, or you can take it later on. You can do a calculation over here. If the 1 and 1 are given, if this 1 and 2 are given, what you are going to get the output? You will be getting 6 and 11. Okay. Now, whatever is coming, another thing, suppose if you multiply here, so here you are going to get 6 and 11. So here you are going to get 6 and 11. And then again you multiply this, and finally you will get 41 and 42 at the output. So network means you multiply and add, and finally you get the output 41 and 42. So this is a 2-layer network. Okay. So this is a multi-layer network, 3-layer network, 1 input, 1 output, 1 hidden. This also like that. So in this 3-layer network, the final output is 41 and 42. So why you need a 3-layer network? Same 41 and 42, you can also get using 2-layer network instead of 3-layer network. That is why it is asked why there is a need of deep neural network. If you can achieve the same thing using a single layer network or 2-layer neural network, then why to go for multiple network? This was same just because there is no non-linearity in it. These all are linear combinations, multiplication, addition. Okay. But when there is non-linear functions, when the input and output are non-linear in nature, then this is not going to work. So you have to go for activation functions or non-linear activation functions. So after summation, you have to use activation function. These activation function can be unit step, sine function, linear. Linear means no input, no change in the output to the output. Okay, input to the output. It can piecewise linear, logistic linear, or hyperbolic transient or sigmoidal. So many are there, and this is a very popular function. Okay, sigmoidal function for artificial neural network. So how to train it? As I already told you, same way you have to do mu into error into x. You have to update it. Okay, and if you have non-linearity, like this particular function at the output of the network, where is the output of the network? So here, instead of the summation, after the summation, you put an activation function, and this function can be this function. Okay, when this function is put over here, then when you take the derivative of this function also has to be taken. Then there will be a concept called delta rule. Okay, and I am giving here some of the concept of the delta rule. So you take the derivative of this. Okay, so when you take this derivative, you will be finding if it is phi, then derivative of this will be phi x into 1 minus phi x. What is phi x? Phi x is nothing but 1 by 1 plus e to the power x. So this which is already calculated, x known, phi x is known. So the derivative of this is nothing but phi x into 1 minus phi x. So the output, whatever is there, that into 1 minus output into error, if you do, then you can update the function. So this function weight you can update using this delta operator. Okay, this is a multi-layer network. So how you are going to train? You get the error and change the weights or the parameters. Okay, you find the change in weight. So this is called delta W is change in weight, and then you add the change in weight. Okay, when you are going to add, you are going to add immediately or after some times. That also has, there are different types. There are different type of network training algorithms, batch training or mini batch training. There are many types of training. I am going to come over there. But this is how the steps. So first, weights are to be initialized to adequate value. It can be either 0 or randomized. It can be 0 or random. Okay, depending on the application. Some value. Then you give the input, get the output, and get the error. Okay, so from the input, this is the output of the network. You have given the input. This is the actual data, desired data. You get the error. With the error, you are going to get the change in weight, and this change in weight will be added here. Okay, so perform step 2 to 4 continuously, again and again, repeat it so that you will get a training. And these are some kind of MATLAB code you can refer later on. And if the data set is like this, so these are the inputs, and these are the input data set. This is the desired data set. Okay, and a small algorithm with delta sigma can be implemented using MATLAB or Python also you can do. So when the data are kept like, so this is the first row, this is the second row, this is the third row, like this data are there. Now you give the, suppose one row, like second row, you have given the input, get the weight changing, and then you update the weight. Like I told here, so once you find out this weight, then you update it, change it. Okay, immediately change. Then that is called stochastic gradient descent method. So you get the error. Here you get one error. Then you update it. Then again you get error here, you update it. Again you get error here, you update it. So if you keep updating at every instant, then it's called stochastic gradient descent. But there is a issue of getting it unstable when the data is wrong. Sometimes data is wrong data coming out in between, so it can make the training unstable. Okay. So, but the speed is better. But instead, what you do is for every time you find out delta W. Every time you find delta W, but don't add it. then you take the mean of this. So average of the weight update first you take for all the value, and then at one time you change it. That is called batch type, and this there will be stability, better stability, and but speed is less. Okay, because you are not changing the weights every iteration. Okay, and in between some people said, instead of waiting for thousands of data to get the output to train, why not go for mini batch? Like let's say this 100 data you take the weight update, do the weight update, then another 100 data update, another 100 data update, like this. So this is called mini batch type. So the speed and stability both are improved. Okay, so this is a simple training. Then there are a linear classifier and non-linear classifier. So neural network ANN works when the linear classifier or linear regressor doesn't work. Okay, so for example, in this particular case, the XOR gate. Okay, or data, suppose this is not XOR gate, some gate, but if the inputs are 0 0, output is 0. Input is 0 1, output is 0. Input is 1 1, output is 1. Input is 1 0, output is 1. So you can find a model of this straight line. So this is a model. Okay, and you can say that left side of this model is all 0 output, right side of this model is all 1 output. But suppose you have another data set when input is 0 0, output is 0, input 1 0, output is 1, this is 1 1, output 0, and this 0 1, output 1. Then you cannot make a straight line like this, saying that left side all are 0 and right side all are 1. You cannot do like this, you cannot do like this, that left side is 1 or 0, like this. So there is no linear line which can actually separate it. Okay, but there is a non-linear line which can actually make it like this, saying that this particular car, within the car we have got 0, both zeros are there within the car, and outside the car both are 1s. So this model can only be achieved by using ANN, and this is an example of 2 input 1 output case. Okay, this is a standard XOR gate, 0 0 0 0 1 1 0, but 0 1 1 and 1 0 1. So this is generally solved by ANN, and this is a multi-layer neural network, and having more layers, then you have got delta rules derived. Because time is short, I am not explaining this one. And then similar training you have to do. Then there are various types of cost functions. So one cost function which I told is desired minus output, then square. And there is a half term multiplied, because when you take the derivative, you are getting 2 into error. So instead of this 2 to remove, you make half over here. So half into 2 will be cut. So this constant is no more required. That is why this half is given over here. Otherwise, there is no meaning of it. And then there is a cross entropy. Basically, when there is a classification type of problem, this can be used for a regression type of problem. I think some people will tell about regression and classification. I am not telling right now. But these are the other types of cost function. And in the cost function, you can add some kind of data called regularization, because this is to remove the overfitting. Overfitting means if the data are like this, some data are like this. Okay, this is basically a straight line. Okay, data are like this. But if you fit it with a very long neural network, it will fit all the points like this, all the points. It will not leave any of the points, making it all completely 0. So you get a model like this, but this is a wrong model. Actually, this is the correct model is this one, because your data is having little bit of fluctuations. You are getting a model like this. This is called overfitting. And to reduce overfitting, you need to do something. Yeah, and you finally use a higher order neural network, but you get a proper model. Okay, and this is a classification problem. Let's say you have got 1 2 3 4 5 like this. These are digits. Okay, it has got how many lines? It's 5 rows and 5 columns. So 25 inputs are there. Okay, so I can give 25 inputs here, Okay, 25 input means if this is white, this particular portion is white, then I will give 1 for this white. If this is black, I will give 0. So like this, wherever 0, 1, 0, 0, then 1, then 1, then 1, 1, 0, 1, 1. Like this, if I give 25 inputs, then here I can say I have got five outputs. Okay. So if the actual input is a pattern of 0, then this will be 1, rest all will be 0. If the is a pattern of 2, then this is 0, this is 1, and rest all are 0. Pattern of 3, this is 1, rest all are 0. Like this, I can generate a data set and train a network. And I can say this is a classification problem. This can have 5 outputs, and each output can tell what is the input pattern. Okay. So using this is all about artificial neural networks, can be used for regression and classification. So we developed we did some research work and got the output. I'm sorry, I'm running out of time and not yet started the CNN. Okay. This is a sensor called LVDT. This is has a nonlinear response like this, and this nonlinear response was compensated. So this is the nonlinear response of the LVDT. This is the nonlinear response of the LVDT, and we cannot use it for long range. So we can only use for this range, okay, which is linear part. But if I put a nonlinear output at the output, then this becomes a linear. So I have a physical LVDT. I put an ANN here. ANN is nothing but a model which is fitting like this. Then these two are combined and you get a controller. You can get a complete whole thing is a linear thing. This whole thing is a linear model. Similarly, we did another application. So how to know the fill level is a big drum having a lot of material inside. So whether it is 10% filled or 20% filled or 30% filled, how to know? We sense a vibration signal of the mill at different fill levels, got the data, extract the features, use ANN, and we estimate the percentage fill level. Similarly, we use a hydrogen plasma where hydrogen and argon gases are filled. Okay, and we take the spectra of it. Spectras are nothing but the wavelength versus intensity graph. And from the wavelength intensity graph, we can be able to estimate using one ANN the flow rate of hydrogen gas. Flow rate of hydrogen can be 10 LPM, 12 LPM or something, you can get it. Okay. Now I'm going to the convolutional neural network. As all these I told about different type of signals and different type of data to be fitted using artificial neural network. But CNN is a completely different architecture which is basically applied for image processing. If you have an image like this, then the CNN can tell whether it is a bird or it is a frog. Okay, CNN can tell. So it can detect the object from video. It can localize the object. So if it is a bird, whether it is here or the bird is over here. Okay, it is just not telling that whole image contains a bird. It will exactly make a bounding box and tell that bird is over here. It is bounded by this particular box. This is called localize. Okay. So what is CNN? Is nothing but you feed the image and it will do a lot of processing and finally tell you what is the object. Okay. So all these terminology I am going to cover now. These numbers and this thing I am going to cover now. So CNN has got the input as image. Okay. In this particular case, 39, 39, 3. This means is a 39 cross 39 cross 39 image. That means 39 pixels in the row column, and 3 means RGB. RGB. 3 colors are there, and in one frame it has got 39 cross 39 pixels. Okay, not a megapixel. Megapixel means 1024 cross 1024. So difference between ANN and CNN is given over here. So what happens earlier days when we were using image processing, we were taking an image, then we are extracting the features. Okay, features we have to extract. Feature means whether it is a black image or a red color image, in the image, how much portions are covered by the object, what is the Fourier transform of this, what is the wavelet transform of that image. So many features we extract and then give to the neural network. So this is the ANN. Okay, this is a ANN. But this feature extraction we need to do ourselves. So this is to be done manually. This is to be done manually. So you take a particular type of picture, I will take another particular type of picture like this. And finally, I will train it. These are the features given to the training algorithm to tell whether it is a dog or not a dog. Okay, so this manual feature extraction process is cumbersome and it is very much expert dependent. That is why people developed a deep learning where this feature extraction and classification both are done together. Okay, so input of the neural network, earlier input of the neural network is just the features. Okay, features are nothing but some numbers 0.5, 0.9, something like that. But here the input can be the complete image or input can be some kind of text. Okay, input can be anything. And the features will be automatically extracted inside it. That is called the deep learning. So how it is extracting? It is doing some kind of operations, and one of the operation is called the filtering. Okay, so or called the convolution. So in the convolution is is nothing but a filter operation. FIR filter, IIR filter. Similarly, 2D filters are there in image processing. So this filter can be how many filters you are going to give. You can give 10 filters, okay, or you can give 20 filters. So in this particular case, you give 10 filters, okay. Then when 10 filters are operated on a 39 cross 39 cross 3 image, you are going to get 37 cross 37 cross 10 data, okay. And in this case, filter and stride is 1, and you have got padding is 0. Padding means, so suppose you have got image like this, you can put some 0 here to remove the boundary effect. Okay, so that is called padding. Similarly, stride means when you are moving. So as you can see, you can see this is shifting, isn't it? So how many rows, how many columns it is shifting at a time? 1 column or 2 columns? Carefully check. So it is 2 column shifting. Okay. So this stride is true here. Okay. Stride is 1 means 1 column shifting at a time. Or stride is 1 over here. Stride is 1. S equal to 1. F filter size is 3 cross 3 filter. Okay. So filter size is 3 cross 3. That is called 3. And stride is 1. And the padding is 0. No padding. If you do that, then you get like this. So there is a formula for this. What will be the future NH111? You can get using this formula. Because of lack of time, I'm not telling that. So this is called the filtering. After the filtering, you go for pulling. What do you mean by pulling? Pulling means if you have the data like this, so this is a 1, 2, 3, 4, 4 plus 4 matrix, and from whole this thing, you take the maximum of 1. So you take only one data. So that is 9 is coming over here. So in the whole thing, you take only maximum of this, that is 2 is coming here. So from here 3 is coming here. From here 6 is coming here. Okay. So this is called the pulling. It can be max pulling or average pulling. Had it been average pulling, you just add everything, take the mean and take one value. Okay. And this is a particular architecture. You can see this is the image. What will be the image size? If you see this number now, you'll be able to understand. This shows that the image size is 227 plus 227. That means there are 227 like this, and there are 227 rows like this, 227 columns and 227 rows. And there are 3 such things, red, green, blue, 3 such individual images are there. And that is going inside. And if you have stride equal to 4, then how much you are going to get? This formula is already told in the last slide. Okay. Then you go for max pooling. Then how much it's going to get? Then after that again filtering with 5 cross 5. Then how much you are going to get? After filtering, you do max pooling. How much you are going to get? Like this pulling filtering, pulling, convolution, pulling. Like this, you go on doing till this. Now finally you get 9216 number of vectors or the values, and this you make it a straight vector, and this straight vector will go to a neural network like this. Like this. So this is the whole data is coming to a neural network, and finally it will tell whether it's a dog or cat. That is called fully connected network. So after 9216, this whole thing is nothing but this kind of artificial neural network what you have studied now, multi-layer neural network. And these are got so many hidden layers, and final output is this. So now in this particular neural network, this particular neural network is called Alex network, AlexNet. Okay, AlexNet. This AlexNet has got 1000 outputs. Okay, this AlexNet got 1000 outputs, and using softmax operation at the output, you can get 1000 outputs, and you can do some hand calculations, and you can get it, get the same stride and functions parameters. Okay, already I have told all this. Now there are well-known CNNs. One CNN I have been telling is called AlexNet. Before that there was LetNet 5. Okay, there are VG16, Inception B1, Inception B2, like this, ResNet 50. So many. So now my assignment to you is find the number of convolutions and fully connected layer, pulling, and primary application of all these networks. So in Google you search. So as I told you, this type of structure will come for each of these networks. Okay, this type of structure will come. So this is one structure. So I am telling you the structures. So this is a LetNet. Hi, this is a structure. This is a one picture. There was a mistake I had found. Okay, and what is the structure and how it is different. So this is a LetNet structure. Then you can say has got 2 convolution and 3 fully connected network. Okay. Similarly, AlexNet. Okay. Check all the values are okay or not. So you can find out all these values by using that formula. Okay, using this particular formula. So this is the formula. So this NH1 is this first one is NH1. Then second one is NH2. The third one is NH1, NH1. So this value you first find, this value you find. Okay. So like this, you can find these values. Now BGG16 also you can find all the values. So overall idea is, suppose there is a car, using convolution you get some kind of features. Then you can use a kind of ReLU. ReLU is rectilinear unit, which is again a kind of activation function to get this data. Final objective is using this kind of feature extraction. You are going to tell what is the probability that this is a car, what is the probability that this is a truck, what is the probability that this is an aeroplane or ship or a horse. But this probability is very high. You can see this green band is higher in case of car compared to truck. That is why it is called a car. So practical advice is you can use open source platform like Python, and there are a lot of codes in GitHub. You can also use MATLAB if your institute is having license for that. Then there is something called transfer learning. So all these networks are well known and already available in the internet. The models are available. You can download this model either in Python or in MATLAB, and you can use it for your application. Suppose this particular network is having 1000 outputs. How many outputs are there? 1000 outputs. That means 1000 types of images it can classify. 1000 types. There may be hundreds of dogs, another hundreds of cat, another hundreds of flower, another hundreds of temple. Then the image is given. It will be able to have 1000 varieties of classification. Now suppose you want to have a classification for 200 numbers of flowers. Okay, you take images of 200 numbers of flowers and you want to use this VGG16 net. So what you need to change? You only need to change the output as 200. Okay, what it will do? Rest of the things up to this. Okay, from here up to this, it will keep intact. Okay, that means this whatever image you have, you may be taking from your mobile camera, but you have to convert to 224 plus 224 plus 3, then feed it, and this 200 outputs, you can make 200 outputs and provide the data, and it will train. It will only train this portion, this fully connected network portion. This fully connected network portion, it will train. Okay, that is why it is called transfer learning. What is data augmentation? Suppose you have got 20 images, 20 flower images. So the rows you have taken, it is a rows, but you have got only 20 images. So the network may not train with 20 images. So what you do, the same image you rotate. Okay, this is an image. You can say that the rows, you can rotate it like this and make one rows like this. So or rotate it upside down and make same thing. So same image you have taken, captured, but you have rotated, you have made mirroring. You can cut it. Suppose from here to here you can cut. Still it is a rows. Okay. So from here to here you cut. So this is called cropping, rotating, shearing. You can just shift it little bit. Okay, make it blur. Color shifting. It's a red color. You make it green color or yellow color. Still it is a rows. So like this, you can create data, new data sets, even if the data is not available for your training. Okay, because for training you need a lot of data. So to use it, before that you need to do leveling. Okay, so image need to be leveled. So this is a bridge. These are the cars. Okay. Sorry, I took 10 minutes more. So leveling can be done by using different type of tools. Okay. So transfer learning I have already told. Then you can implement using PyTorch or Keras. There are a lot of things you can use. I think I have covered most of the things what I intended to do. Thank you very much. So any questions?
Thank you, sir. And thank you for enlightening us with your talk. I think all of us have been benefited by this talk by Dr. Das, sir. And thank you for connecting with us and sparing time from your busy schedule. Now I request the participants, if you have any questions, then you can ask with the sir. Sir is with us for next 5 minutes for the question and answer round. So if anyone wants to ask anything.
Hello.
Yeah,
It's
yeah.
audible?
Yeah, it's audible.
Yes, sir. Sir, actually, at the starting time, you told artificial intelligence is very helpful for neural network and memory. Actually, I am working on memory design for neural network. So, how we can implement this neural artificial intelligence for neural network memory design? Means memory neural network. I want to link with the help of artificial intelligence.
So you mean you are designing memory in the VLSI circuit, or what type of memory?
Yeah, VLSI.
Okay, so basically you are designing the memories, and memories having storage elements, and you have got data bus and memory address bus. All these will be there. So in various places you can apply this neural network. For example, you want to optimize something. Okay, maybe your size you want to optimize, and you suppose made some layouts for different memory architectures, and finally you find some kind of memory. Some kind of space optimization. So your output is space that is to be minimized. So you can actually model your complete memory design process using a neural network. Whatever input you are giving, so for your memory design, you have got several types of inputs. Okay, so in your mind, you are putting that my size of all the transistors will be like this, or my architecture will be like this, or my sense circuit will be like this. So for something you have to design a model. Okay. So input and output, you have to create the data, and this data can come from your simulation, like your suppose you are modeling using cadence or something. You can get the data from there and develop a neural network to fit the data and see that whatever cadence is doing using the all the VLSI, all the transistor equations, everything they are using at the back end, and you are getting some result at the output. Same thing you can do using a neural network. Now next time you need not go up to the cadence to make a new layout, okay, and you can actually make your neural network equivalent to a cadence tool. Okay, I think a similar kind of approach you can do to design new type of memory using the models which you have derived based on your experience with the memory design and cadence. Is that sounding okay? Or we can have further discussion if I get into know about the
Yeah, okay. Thank you, sir. Continue to the sir's question that you have told that the different equations we have, what we are having in the cadence design. So have the neural network, we look forward to the lookup table based design for first time when we are designing the neural network for our device or circuit level. That we are designing the lookup tables for our capacitances, internal capacitances, currents to train the neural network for that.
yeah, lookup table is just discrete. Okay,
Yeah.
lookup table is discrete. So if you have a model, all the lookup table you can model with individual neural.
Yes. Okay. Thank you, sir. So, if any participants are interested to ask question with sir, uh, one can ask. So, I think we do not have any questions now. So, I would like to again thank you, sir, for giving us, enlightening us for our talk and sparing some time from your busy schedule as the guest. And we have been enlightened us to have you as our eminent guest and keynote speaker from your end. Thank you, sir.
Thank you very much. I hope this was not very fast because it was just 1 hour, 2 concepts I had to cover. Yeah, whatever was possible in 1 hour, I could have. You can
No, sir, it was very much informative, sir. We have been associated with you for one last hour from the basics to some problem statements for the machine learning and artificial. So that was the best thing we have. Thank you so much, sir. And we hope that we would be welcome you in near future also, and you will be sparing time with us.
Sure. Thank you very
Yeah.
much.
Okay.
I
Thank
can
you so
leave
much. Yeah, yes, you can.
now. Thank you.
Thank you so much. Yeah, participants, we will be starting the next session by 1 p.m. So at 1 p.m. sharp with our next speaker of the today's session. So till then, you all can have rest or have your lunch. Thank you.